Hi, I'm Sarah Grady. I'm a graduate student at Michigan State University, and I study media and narrative psychology. And I'm presenting this paper on behalf of myself and my co-authors. In particular, I want to thank Dr. Ralf Schmalzle. We looked at how shared brain activity varies over the course of a narrative, particularly in brain regions associated with social cognition and story comprehension. Now, I'm going to unpack that a little bit before we get into the research and study design itself. So first, this is coming from the sort of baseline assumption that the brain is an intermediary between a media message like a film and its audience. We need our brains to process and make sense of that information. The way that we synthesize it impact how we experience that content and how it makes us feel and what we do with that information afterwards, which is a pretty understandable assumption. But that means when we think about the brain as an intermediary, we can look at what is the brain doing during processing. And more importantly, for someone like me who's interested in how media affects people, we can look across brains. We can see what is the shared brain activity doing. If we look across a group of people, sure, they all have different brains and different thoughts and feelings. So where we see shared activity or where we see the brains doing similar things can tell us something about how that piece of content or that segment of film is bringing everyone into alignment. We're sort of in sync in the way that we process the content if we see shared brain activity happening at certain points in time. So broadly, here we're going to use intersubject correlation, or ISC, as an index of how similarly or differently audience members' brains are responding to the same piece of content. So we're going to look at all the brains compared to each other, and a high ISC coefficient means that there's similar brain activity happening. A low coefficient means there's divergent or different brain activity happening. There's not a lot of shared processing going on. So I'm not going to get into ISC a huge amount, like Hassan's early work was even in projection, so hopefully many of you are familiar with this, but I'm happy to talk about it in more detail in the Q&A. Now, IAC has been used to study a range of film stimuli and also audiobooks, short stories, popular speeches. And we can see that ISC varies with different kinds of content. So for example, ISC is higher during suspenseful scenes than non-suspenseful scenes in a thriller, for example. So it's kind of a good marker that when people are drawn into a story, ISC gets higher. This marker of shared attention goes up because we're all processing in a similar way, or at least we're all invested and our brains are online in similar places. Now, in the really early work on ISC, they were looking across the whole brain or across a whole movie, but we can also break it down and calculate this correlation coefficient in a variety of ways. So we might look at a particular piece of the brain, a particular section of the brain, say the visual cortex or the audio cortex, and we can also break it up over time. In this paper, we particularly want to look at ISC as a marker of shared neural activity during a film in brain regions associated with social cognition and story comprehension. Because a story, by its nature, is full of characters who interact, things happen, and the plot unfolds, we wanted to see what's happening in the mentalizing network, in the social cognitive parts of the brain, over story exposure. We also look a little bit, and I'm going to breeze over this today, how this pattern may vary in adult and child audiences because social cognition develops with age. So theoretically, the foundation here is that stories run like mental simulations. So we're building mental models, we're making predictions about the story world and its inhabitants. And that as we follow protagonists, we intuit their thoughts and feelings. We make predictions about their motives and their outcomes, and how we feel about them, how we think about them plays a large role in how we judge them, how we appraise the story, and what we take away from it afterward. Now, these social cognitive processes about character, like theory of mind, perspective taking, empathy, are very similar. And so therefore in the brain will look very similar to the way we process the social information about other people in the real world. So we're going to look at the mentalizing network, a set of brain regions that are specifically been associated with social cognition in real world settings. So that includes the tempoparietal junction, the medial prefrontal cortex, and the precuneus. There's a little map here at the bottom of where those are physically in your brain. Now, importantly, there's been some work in narrative and literature in brain research that shows that these same brain regions, this mentalizing network, is also heavily implicated in story comprehension, which makes sense. We need to understand characters to understand stories. So they sort of borrow from the same processes to work. So it makes sense that our social cognitive processes are online, for lack of a better term, when we are processing story information. So our most basic hypothesis here is that shared neural activity, or ISC, is going to be high in the mentalizing network. We're going to use our social cognitive processes to understand a story, so we should see high ISC in these brain regions when people watch a movie, which is pretty obvious. But more interestingly for us is acknowledging that narratives aren't a static thing. Looking over the course of a whole movie isn't nearly as informative as looking over sections of it as the plot unfolds, or scene by scene, for example. So what we decided to do was look over the way a narrative changes, that sort of build and release of dramatic tension as a director of attention that's sort of bringing brains into alignment and making a higher ISC of shared activity here, by breaking the narrative into sections and comparing ISC over time. So we adopted one of the most basic models for this, a sort of Freytag's pyramid, a 5-act structure of there's an exposition, a rising climate, a rising action, the climax, and then some denouement. Now, this is basically middle school English class in a nutshell, right? There are lots of other ways we could have done this. I hope during the Q&A we can talk about that. But essentially, we said, let's break the story into its most basic acts and then look at ISC in these different sections of the story. So we expect that as the audience gets invested in the story, they get drawn into the plot, as the dramatic tension rises, ISC will also rise. So it should be higher in the climax than it was early on in the story, which makes sense, right? We all come into the room with different things. So the mental models we draw on during the exposition may vary, but as we get drawn into the story world, we will all start to think about it in more similar ways, or at least understand it more similarly. So we'll see higher shared activity in the mentalizing network at the climax than earlier on. But we were less confident in a directional prediction about later in the story. Once that climax happens, do we all stay invested and entrained and see high ISC all the way to the end? Or does everyone sort of fall out to their own idiosyncratic thought processes once they know kind of what's going to happen? So we left it as a research question, but we're curious to see either way what would happen towards the end of the story. Now, the other piece of the puzzle, I'm going to skip through this really quickly, is essentially that social cognition develops with age. Toddlers are really crappy at knowing the thoughts and feelings of other people compared to adults and older kids. But by the time you get to sort of middle school, 11 to 13 here, and this age across the x-axis, kids are much better at knowing and recognizing the thoughts and feelings of other people. So if these social cognitive processes are an important piece of story comprehension and processing, we would expect this mentalizing network to be differentially active in younger audiences than older audiences. So we wanted to look across different age groups in this brain network as well. So the study design as a whole, we took secondary data from a previous study in developmental psych lab, Richardson and Sachs and their team. It was the Pixar short Partly Cloudy, which is about 5.5 minutes long, and they put people in an fMRI scanner and had them watch the movie and just scan their brains. We're going to particularly isolate some specific brain regions, but there's a whole bunch of other data in there we can talk about another time. And then we binned the audience based on their age. So we had an adult sample where we would look at what grown-ups' brains were doing during this film. And then we broke the kids based on developmental psych literature into sort of preschoolers, middle-aged kids, and older children. Then we needed to code the film. If we wanted to look at how the exposition versus the rising action versus the climax might command different levels of ISC or more shared attention, we needed to decide where those act breaks were happening. So we had a group of coders with a code book based on some screenwriting materials, break the story up into 5 acts. We had really good reliability between our coders, except in one spot. Deciding the exact second that the climax tips into the falling action was a hard point for people to differentiate. And more importantly, when we're thinking about social cognitive processes, that exact second of time isn't necessarily particularly meaningful. The climax and what happens afterwards, how those fit together, are part of the same piece of the puzzle. When you're thinking about a fight scene, it's not when the guy gets stabbed, it's the whole fight scene is the climax. It's sort of one way to think about this. So we ended up folding the climax and the falling action, or sort of immediate fallout, into one segment here. So we have 4 plot sections that each had specific timestamps that we could then compare ISC over these sections of the story. So here's what we found overall. First, we look at static ISC, or the ISC over the whole movie. And we can see in this heat map that the paler the color, the higher the ISC. So unsurprisingly, and in line with all previous work, it's highest in the visual cortex because, surprise, everybody's looking at the same thing. It's also, importantly though, for us, high in these blue circled areas, that mentalizing network that we're interested in. We also see high ISC. We then looked over these narrative sections, and we see the ISC coefficient rises from that early exposition and is highest at the climax and stays high till the end of the story. This is the end of the resolution here, is when the credits begin to roll, is the way we cut that. So in this mentalizing network, we see more similar brain activity in the mentalizing network later on in the story. It sort of grows as the dramatic tension rises. In the kid audiences, we see more similar activity. I'm just going to jump to this slide here, and you can pause if you want to have a look in detail. But essentially, the older kids are more like adults. The younger kids are less like adults. And notably, the ISC coefficient is lower for the littlest kids. So there's even less sort of agreement among the little kids themselves. Not only are they different from grown-ups, but they're sort of different from each other. There's less shared activity overall in that group. So in general, we see that the shared processing, or this ISC, is happening in the mentalizing network, and that it increases as the story unfolds over these act breaks, and it remains high till the end of the story. And that kids processing, understandably, their social cognitive processes are not as developed, so for younger kids, the pattern is a little bit different. I want to recognize that because this was secondary data from Richardson and Sachs, which we thank them profusely, it has been amazing to have secondary data to work with during COVID when you can't put anybody in the lab. But it also comes with some problems. We couldn't ask follow-up questions, for example, like what were the kids paying attention to? What did they like about the story? Which we would have loved to ask, obviously, but this data set is just not set up for that. We also made some methodological decisions about the way we normalize brains and stuff. We can talk about those details if you're interested in the Q&A, and that there are other ways we might have coded the story. Adopting a 5-act structure, or what ended up being 4 segments, is only one way we could have cut this apart, but we could certainly do this with other scene-by-scene analysis in different ways. We could have looked at Zach's event segmentation processes, for example. So it might be something for us to discuss together about different ways we might cut a narrative apart and see how audience brain activity is shared or divergent over those sections. The thing I want to leave you with here, the sort of last piece of the puzzle, is that often this research, when we're looking at brains during a movie, stops with the brain activity, right? Oh, we saw high brain activity or low brain activity, shared activity or divergent activity, and that's it. But as somebody who's interested in content, how and why movies make us feel the way they feel, how and why they might have us all think and feel together collectively during moments of high tension, for example, we wanted to go back to the content to ask, okay, great. There are points where shared activity is higher than it is in other places, but what's happening on screen at that point? What's going on in the story? And sort of reverse it back to the content so that we could ask some questions in the long run about what the stories are and aren't doing, or what it takes to command this ISC if you wanted to design narratives to these ends. So here, sorry about that. Here we have a reverse correlation analysis. So this is no longer an ISC. We're not looking over time. We're looking instantaneously at each point in the story. We're looking, is activity high in each person? And when it is high across everybody, then we have a peak here. So this means activity, particularly, this is the right tempo parietal junction. In this part of the mentalizing network, everybody seems to have high brain activity at these points in time where the circles are. So now we can go back to the timestamps and say, well, what was happening in the movie at those points? Now, Ralf has made a little trailer that's a little bit long for me to show right now, but essentially these 3 sections of the movie are points in the story where the stork and the cloud, the 2 little friends that it's about, are having important exchanges. So for example, in the first one, the cloud makes a baby, he gives it to the stork flies away to go deliver it to its parents, the cloud waves happily and then is sad he's by himself. In the last one, the stork has been beaten up, is having a terrible time, and it flies away to a different cloud. And our little cloud gets super sad and upset. He thinks he's been abandoned. And right at the end of the section, he turns into a giant thundering storm cloud and bursts full of rain. So in all of these moments where we see high brain activity in the RTPJ, in this part of the mentalizing network, these are scenes or sections of the story where a lot of social interaction is happening. There are a bunch of close-ups. There's a lot of emotional information being conveyed in their faces. There is dynamic exchange between these 2 social actors that we've been following over the story. So intuitively, it makes sense that the RTPJ is particularly active across our audience when this social information is being conveyed. Now, this is still very exploratory. Obviously, it would be beneficial for us to look at the troughs, right? When is the TPJ not highly active across our audience? When do we see these peaks in other parts of the brain that are implicated in social cognition or in other types of thinking? So clearly this is just one little toe in the water, but it's a good gut check to say, yes, this brain region that's implicated in social cognition, we see a lot of activity there when there is a lot of social information and social exchange happening on screen, which is heartening, I think, when we want to look at how stories are impacting people and how the thoughts and feelings and interactions of those characters are impacting our social processes internally. I'm going to leave it at that for now. We're kind of excited that this paper looks at neural data, but marries it with neurological theory about narrative structure and story comprehension. And we think looking at the mentalizing network in particular during online social processing while they're watching a movie is a pretty cool way to do that. So there's clearly some caveats and limits. There's plenty more questions to ask later, but because we could watch their brains in real time, we could see some things that we wouldn't have been able to get with just a traditional post-exposure survey, for example. So thank you for your time. I really look forward to hearing what you have to say and answering your questions when we meet in a few days. Thanks so much.